This little precipitation lesson is going to show you, actually it's not kind of neat. I got some more recent stuff that's going on this week, the week of the 18th of the next storm system that's coming in that'll kind of show you the whole, what type of precipitation you're going to get. But to get precipitation, well, obviously got to have clouds first, so you got to go through that cloud formation process. But you have the collision coalescence process that takes place. So in the collision coalescence process, it occurs in warm clouds, so you're typically going to see this more in like a summertime situation where the clouds are above 32 degrees Fahrenheit. And what all that's going on is you have your raindrops are starting to stick together and they get, bigger and bigger until the cloud can't actually support it and it ends up falling. And that's when you get those warm rains. The way that happens the most, the Bergeron process is the one that takes place a lot more in the atmosphere, and that's where you're going to have the clouds are below 32 degrees so Fahrenheit, so they're in the freezing range, and you're going to have what's called supercooled water take place. Supercooled water is water that's still liquid even below freezing temperatures, and it occurs about from 12 degrees Fahrenheit to about 32 degrees Fahrenheit. After that, if it gets any colder than that, then you can have some supercooled water, but you can mostly have some ice crystals. So it's a very neat and just really neat thing that the water can do. I mean, water can still be liquid and it be freezing out. And you might have seen this before if you've ever left like a water bottle in your car and it's freezing outside, and you come back after, the car's obviously gotten below freezing, and then the water is still water, and then you touch it and then it starts to crystallize and you get like kind of a slushy water after that. That's the same thing that's taken place. It's really kind of neat if you've ever actually seen it. And so what's taken place is you've got supercooled water droplets, and it's starting to grab onto these ice crystals, and so the ice crystal will get bigger and bigger and bigger, and then you'll get snow to fall. And actually, almost all precipitation starts as snow, even in the summertime. So you're going to get snow starting, because the big deal is going to be what the temperatures are after it falls off out of the cloud. So if the cloud temperature is freezing upwards taking place and you get it start as snow, if it's warm the next layer down, then obviously it'll melt to become rain, and if it's warm all the way down, it'll stay as rain. So most precipitation starts as snow, even in the summertime, unless you're getting that collision coalescence process take place, which happens, more or less in the summertime and doesn't happen nearly as often as the Bergeron does. The Bergeron fendescent is the technical name for it. So here's a good example. There's a temperature profile and then what it's looking like in the atmosphere. So you got your cloud. On the top picture, what's taking place is how you actually get rain. Next one, you can see that the temperature stays below freezing from the time it goes from the cloud to the ground, so it's snow. You can get what they call sleet, where you have it start as snow. There's a layer in between where it melts, and then there's a deep enough layer for the rain will actually refreeze into an ice form and then strike the ground. You've got freezing rain, or what people call glaze. Same thing happening where it falls from the cloud as snow because it's below freezing, and then there's a deeper layer of warmer air and it melts, but right at the surface is where it's freezing again, so it strikes the surface and it freezes contact with the surface. So those are the differences and the types of precipitation. Now, the event that's coming up for the 21st of February, this is a midnight forecast of what's going to happen. So you see precipitation is on its way in. And then for the next part, you got your temperatures. You can see the temperature is somewhere between 25 and 30, so it's going to be below freezing at that time as well. This is 925 millibars, so just a little bit up into the atmosphere, and it shows the solid blue line is the freezing mark, and you can see that where Kansas City is, then well below that is where that line is, so that means right above the surface is cold as well. And then if we go one more, this is 850, so I'm going up just a little bit more into the atmosphere and it's still cold. So this is suggesting whatever starts as snow. And again, this is a forecast, so it could change easily. Now the next part is, this is 18Z, so this is noon on Thursday forecast again, and it shows obviously lots of precipitation over the Midwest, most of Missouri, parts of Kansas, Nebraska, and Iowa. So there's a lot of precipitation associated with this low pressure that's coming in. And at the surface, it's still showing us to be cold, because it's in the 20s. But then as you start to go up, you see at 9:25, now that blue line has made its way back up a little bit further north, so it's almost kind of sitting around the Kansas City area. And then if you go up again to 8:50, it's the same thing. So now there's this little layer that's warmer, where you could have it start to snow, it's going to melt, and then it's cold at the surface, and then it will freeze on contact. So right now it might suggest more like freezing rain, like going from snow changing over to freezing rain. But again, this is several days out, where this placement of this 0-degree line just above us and how deep that layer is makes a big difference of whether you're going to end up with sleet or freezing rain, or maybe it just ends up staying as all snow. So you'll have to keep watching this, but you can see how forecasting for freezing rain and sleet, it's kind of hard. I mean, one, you got to know exactly where this 0-degree line is going to end up, and then you know just how deep these layers are going to be, because how deep when it melts makes a big difference of, is it going to end up being more of a freezing rain situation, or is it going to be able to have a deeper cold layer where you can refreeze it into an ice pellet to make some sleet. So it's pretty tough to forecast these kinds of events. So keep that in mind when you're watching it on TV. And again, I mean, obviously that line is just right on top of us, so it makes it even harder, because if that line's just, even 10 miles to the north, makes a big difference. If it's, 10 miles to the south is where it sets up, makes a big deal of which way it's going to be. So right now it looks like starts to snow, changes to freezing rain, but again, we'll have to keep watching to see how that actually plays out. And since this is in the week 6 folder, obviously this event will take place during week 5, and so I'll be able to update you and show you what really happened, so you can look at what was forecasted and what is going to be what will have really occurred, and be able to compare the two and see, really which way was it? Was it freezing rain? Was it sleet? Was it all snow? Or was it all rain? Because sometimes these systems can do that to us, where it comes in so close like this, and it just ends up being all rain. So either way, it's going to be precipitation that's well needed. So that's the good news.